the other engines. And I'm very grateful to this beauty of this language that these guys have brought to us. And I'd like to invite you all to celebrate with us and ask Roberto Ierusalimschy to come and talk to us about the making of Lua. It's a rare opportunity for us to celebrate such achievement within our community. Thank you. Roberto.
Thank you. Well, thank you, everybody. Well, Lua is actually a co-work with Luis Henrique Figueiredo, that is here, and Valdemar Celis, that is hidden behind there. And so in this talk, I will talk very little about the history of Lua, just some highlights of what happened, and a little about why people use Lua, and a little about who use Lua currently. So this is more or less the structure of the talk. So I have this strange thing here. No, I don't know where it's. Yes. So Lua started in 1993, so we are celebrating 25 years of the language. I mean, of course, as I said, it started, it's been evolving during all those years. And it started inside a TeX graph, which is a project that still exists today between our university, the Pontifical Catholic University, and Petrobras, which is the Brazilian oil company. And the problem is a very common problem. That is actually, we had two programs with configuration problems. We needed a language to configure applications, a language that end users could use to do some stuff, to adapt the program to specific scenarios. And at that time, the two programs each had its own mini language. It was very common, still a common approach today. You create a very small language for the problem you have, and then you notice, oh, I should have comparison operators in my language, and then suddenly, oh, it would be good to have some mathematical operators in the language. Oh, variables wouldn't be a bad idea too, and then you start adding stuff, and in the end you have a mess of a language without any pre-design, and still with a lot of missing parts. So we decided to create a minimal language, but a consistent language with some kind of traditional structures like loops and variables and functions and parameters and stuff like that, but also with very strong data description facilities. And so we came up with this idea of a generic configuration language that got the name Lua. And at the time, the Lua it was not created, it never was an academic language. I mean, although I do research in programming languages, I did not create Lua to do research. It was not a language that we created to write papers about. We created the language because we needed the language for that particular use. And so before creating the language, we tried to see whether some other language could fulfill our problems, could solve our problems. And so one could be a candidate for the data description part, could be XML, but XML didn't exist at that time. And it's not a proper programming language. As I said, as soon as you start using XML, oh, it would be good to have variables, to have some dynamicism in the language. Perl would be an option, but it's very complex, very big, and it's not easy to embed into other programs. Python, again, it's not very easy to embed into other programs, and was still in very, very early versions in 1993. And in that time, there was TCL. That could be a good option in terms of architecture of the language. But again, the language, it has a very complex syntax, or I mean, I'm not sure if you're familiar with practical, and I'm not sure we can call syntax what it offers, but anyway, it was kind of complex for because we have to remind that we were talking about a language not for programmers, but for end users that know something about program, but are not professional programmers. So we wanted something with reasonable syntax, with reasonable error messages and things like that. So in the end, we decided to create a new language. We'd say, okay, it's not that difficult. We can create a reasonable language to solve these specific problems. So we created this idea. I said, let's call it an extensible extension language. I will talk more about this later. And we use the idea, now it's called extreme programming, the simplest thing that could possibly work. So for instance, at the time in the first implementation of Lua, tables that are, when we talk about tables, we think about hash tables, but they were not hash tables, they were just linked lists. When you access a field X, it just goes through the list looking for X. That was the very first implementation. And it was very conventional. It was a precompiler with LAC, YAC. It generated opcodes, and it was a very small project, but it solved what we needed at that time. And, we can use here. And it has a very good acceptance there. It solved our two problems, and then soon other programs inside TeX were also using Lua. I mean, people start to see, oh, this could be good. Because exactly, it was very, very small. It was very cheap to put Lua in your application, and then you start exporting some functionality to Lua, and then end users could automate some stuff, could create macros and things like that. And so in 1 year, we have more or less 30 programmers. That at that time was more or less almost all the universe in TeX, all people in TeX were using Lua. And of course, there was no impact outside TeX at that time. In particular, it was a kind of a language created at the Brazilian university who was going to use that. It's kind of... And so these are some projects at the time. People started using to configure user interfaces and that kind of things. Mostly interfaces, there is something that changes all the time. You have to adapt that stuff here. You have to change some text there. You have to change colors. You have to change scales and things like that. And then I think, I'm not sure if this was idea of Luis Henrique, to send the message to users group that this is very old stuff, users group. He was doing, was a postdoc at the University of Waterloo, and then he sent a message for several users groups. It's here, the compilers, language miscellaneous, etc., announcing the release of Lua, and then people started very slowly using Lua outside PUC. That was in 1994, so probably we were in our second release of Lua. I mean, with 30 users, we already had to improve the implementation in several aspects. We already had written a manual, because all those users knocking in your door asking for how do I do that, so you have to have a decent manual to avoid all those questions. And then after you see, 3 years later, we wrote some publications. There was a more academic publication in Software Practice and Experience. And this Dr. Dobbs, I don't know who is familiar with this magazine, was very, very popular at the time, and it was very good. They sold them in newspaper stands, news stands. And I think that actually this article has a much bigger impact than this one. Nowadays, everybody refer to this one as it was important, but actually that one was the important one. And so almost, I think, 1 month after the publication of that one, we got this message. from this guy at the LucasArts company, exactly explaining that he read the Dr. Dobbs article, and he decided to try to use Lua. Here is the important part here. Then he decided to use Lua in the game he was writing for LucasArts. And then 2 years later came Grim Fandango. That was a very popular, what they call the AAA game. It's a very serious game with a lot of investment from a big company. And it was a big success. And actually, this game was what made Lua became some kind of mainstream language. It's maybe strong, but it became much more popular. I think to explain what happened here is this is a meta slide, or it's a meta or is a meta slide? I don't know. I'm talking about him giving a talk. Yeah, this is just a meta slide, okay. This slide is a meta event because it's a slide describing something that happened, and I am describing the slide that describes something that happened. So he gave this presentation at our first Lua workshop in 2005, talking about his participation in a roundtable in the Game Developers Conference in 1999. There, as it's written here, this was a panel to discuss the use of scripting languages in games, and he was not in the panel. He was in the audience, and this is here, these 200 miserable people. That's his description that he said after the panel. The final conclusion was kind of like, there is no decent scripting language for games. That was the conclusion of the panel. And he was in the audience, and then he said, excuse me, I beg to disagree. I had a very good experience with Lua. And then he had Grim Fandango to back his claims. I mean, this is a very big difference. Say, oh, I use Lua and it was very good. I use Lua and I did Grim Fandango that everybody knows, everybody plays. And then this furious scribbling. And then those 200 people, that's how Lua started to propagate. And if you measure, there is some kind of measure you can do about that. In this Lua workshop, when he presented that, there was maybe 50 people in the audience. And of those 50 people, at least 3 heard of Lua in this event. So it was a really... many years later, you get 50 people, and 3 came from this. So this was the main point where Lua started to become more popular, and people started using first in games and then in other stuff. And then soon several other games were using Lua. One popular, we got Lua Bar, the name of the bar in the game was renamed to Lua after. So this is Escape from Monkey Island, also from LucasArts. It was released in 2000. So this was more or less how Lua became somewhat popular, how we escaped from a university in South America to... was an article in Dr. Dobbs, and then a crazy guy working at LucasArts. But then why Lua? I mean, of course, we had some luck. That guy, he himself said, if I knew better, I would not use Lua, because, I mean, I would not risk my career. But I was just fresh from the university. Why not try something completely that anyone had tried before? So he had the courage, or I don't know if it deserves to be called courage, the lack of knowing that it's dangerous, but anything. Anyway, he did that. But, so why Lua? It's just another scripting language, but exactly we created the language with very specific goals, and those goals made a big difference between Lua and other scripting languages. And in particular, I talk a little about this goals, portable, small, simple, and this emphasis on scripting, it's very important. So portability, at the time, now it's not that way, but when we started Lua, portability used to mean, oh, it runs in Windows and Linux, or Unix, not even Linux, yeah, it was. So it runs in Unix and Windows, then it's portable. No, portable for us means it runs in almost anything, in microwaves, it runs in cars, in watches, in whatever there is a decent CPU with some minimal amount of memory, you can run Lua. For instance, it runs inside OS kernels like the NetBSD. It runs directly on bare metal in platforms without an operating system. So it's really very portable, the code. The second, the size. Lua, it's a very small language. This is the number lines of code in the evolution of Lua, of the language, the libraries, everything. As I said, we started with less than 6,000 lines of code. It has a kind of linear growing. It's not an exponential. This is not logarithm. So it's still a very small piece of code with less than 25,000 lines of code. The pink one is logical lines of code. It's mainly counting semicolons in C code. It's a reasonable, simple language. This is hard to measure, but as a kind of proxy to simplicity, we can use the manual of the language. The manual describes the language, describes the API with C, describes all the libraries, and everything. It's in a book that is this thick, so you can have an idea. This is all you have to read to know everything. Of course, to understand, it needs practice, etc. But the real information, everything it's here. And why it's simple? The main thing in Lua is this idea of very few mechanisms, that it's very generic. So for instance, it has only one data structure. There is the tables, there is associative arrays, and everything in Lua is implemented as associative arrays. I mean, everything, all kinds of data structures. So arrays are just associative arrays indexed by integers. Records are just associative arrays indexed by strings. And even objects in object-oriented programming, modules, everything, all kinds of structures in Lua are implemented with the same data structure. We have closures. There is higher order functions, first-class values with lexical scoping. There is also a very, very powerful mechanism. We have that for a long time in the language, and we use that everywhere in all kinds of situations. It's very pervasive, the use of closures in the language. That's not. Now several modern non-functional languages have closures, but they do not use closures as pervasively as Lua. And we have coroutines. That is also very good structure for abstractions of control, things like iterators and even multitasking. So these three stuff, the arrays, closures, and coroutines, form the basis of almost everything that we have in Lua. And as I said, scripting, it's a very, very selling point of Lua. Nowadays, there is a kind of mixture between scripting language and dynamic languages. But when we talk about scripting in Lua, you are using a kind of older meaning of the term, that it's a language that he used to control other languages, to control other programs, like a bash, like a shell in Unix. And so we have this idea that the program is written in at least 2 different languages, that there is a scripting language and what it's called the system language, that is typically C, C++, or maybe even Java. And we heard about even systems written in Python being scripted by Lua. I mean, Lua is really used for scripting in a large variety of other languages. And the idea is that the system language implements the hard parts of of your program, the algorithms, the data structures, everything that is complex and needs performance. And usually these are the reasonable, stable parts of the programs. You do not keep changing our algorithms every day or keep changing data structures every day. And the scripting connects these parts in some ways or do some arrangements or some final touches in the program, like user interfaces and things like that, that change much more frequently than the hard parts. So one thing that a lot of people do not realize, and it's very important in scripting, is that there is 2 approaches, 2 ways that people use scripting. That is traditionally called extending and embedding. And the idea of extending, and why we call Lua an extensible language, is that you have your language like Lua or Python. You can write libraries in another language to be used in your language. So you are extending your language with other stuff. And this is the idea that people usually associate with scripting. People have a very strong emphasis on this aspect, that you can write libraries. So, okay, I have a good database library, SQL, some kind of implementation, and it's easy to write a library, so I can use that library in my favorite scripting language. So this is very common. Most scripting languages do this well. But this other aspect that it's also very important, and it's, for instance, how Lua Tech uses Lua and how a lot of games use Lua. It's what it's called an embedding, that the application, it's not written in the scripting language. You do not have an application written in Lua or an application written in Python. You have an application written in C or C++, and you want to, from this application, to call functions written in the scripting language to configure, as I said, to do some specialized work, to do some extra stuff, to paginate your document or whatever you want to do. And this aspect, it's not very well supported for most scripting languages. And Lua, since the beginning, had actually, in the beginning, maybe it was even stronger in this aspect than that. But anyway, since the beginning, it was designed to have these 2 aspects. That's why it's called an extensible extension language. I mean, it is an extension language because you can use it to extend other applications, and it is an extensible language because you can extend the language itself. So, and in Lua, many programs that use Lua use both aspects together, so it's very common. You have a stack of calls in Lua. You have C code that calls Lua, and Lua calls again C code that then calls again Lua, and you have all that mixing working together. And something that is very important, some people miss when we talk about scripting, when we talk about performance, about size and simplicity, not much, but even portability, people usually think about the implementation, but all those goals have a very strong impact in the design of the language itself. So here we just 2 small examples. For instance, exception handling. In most languages, exception handling is done like this. You have a try block, you do some stuff, and if there is an exception here, you go to the catch, and then you have the exception code. This is the traditional this is not how Lua does exception handling. Lua does exception handling in a very unconventional way. In Lua, exception handling is done through a function that is called pcall, from protected call, and as the name implies, protected call calls its parameter in a protected environment. So it will run this function, and if there is any exception in this function while running this function, then pcalls kind of captures that, catches the exception and returns normally with a Boolean saying whether there was an exception or not, and if in case of exceptions, a kind of error message or exception message, exception object, whatever you want to return. So, of course, this code is nicer, it looks better than this one. What are the advantages of this approach related to the goals of Lua? First, it's very simple semantics. For instance, all those questions that it's very common in exception handling. What happens if there is another exception in the catch? What happens if I return and there is a final block? There is all those kinds of complications that here it's very simple what is happening. Whatever happens here, you return here. If there is an exception here, it's very clear that what it happens is this exception will be propagated, not the other one. So everything it's simpler. We need no extra syntax in the language. There is not a big advantage, but it always simplifies a little the compiler. And the main advantage is exactly the scripting aspect. To present that to an API, I mean, how from C I can interact with stuff like that. And here it's very trivial. You just put in your API a function equivalent to this one, and then, for instance, in C you can call you can do protected calls of Lua code, and vice versa. If I do a protected call and here inside a call C code, I have all those kinds of protections, and it's very easy to interface. In fact, more often than not, in Lua, protected calls are made from C, exactly because when you're using Lua for extending something, if there is any kind of error, usually it's the application that will handle the exception and not your code. So more often than not, this protected call is done from the API and not from Lua code. So this is something that was designed to be easy to interface with other language. Another example are modules in Lua. In Lua, modules are just tables populated with functions. So for instance, you require a module and you print the square root in the math module. This is actually returns a regular table. This is a table access, and inside that table you have a function, and then you call that function. So again, it's a very simple stuff using what we had. As I said, we use tables and closures to implement that. We have several extra facilities. You can rename stuff, etc., just because everything are regular values in Lua. Why this is good? Again, we need very few new features. Mainly here, we only need this function required. This, again, is a regular function that will look for files, load that files, and return a table as the result. It's flexible, it's easy to adapt, etc. And most important, it's very easy to integrate with other languages. Again, if in the API you have ways to access tables, to get fields in the tables and call functions, then it's very easy from C to call functions inside libraries, and from C to create libraries. You just have to create a table and put functions inside that table. So again, scripting is a very important consideration in the design of modules for Lua. And so, in Lua Today, I'll talk very little about where Lua is being used today. The original goal of Lua was scripting for applications. As I said, you have regular programs that use Lua for extension, for all kinds of different stuff. But Lua also became very strong in embedded systems because it's very small and because of this idea of scripting that it's very controlled environment, and because of portability, of course. And also because of those goals, it has a very strong niche in games. So here are a few applications that use Lua. For instance, the Adobe Photoshop, actually, this one is crazy. This one is the only one here, I think, that does not use Lua embedded. It's actually use Lua. The program is mostly written in Lua, and it uses C, C++ for the image manipulation, I mean, the hard parts, but more than half the code is Lua in the Adobe Photoshop. The other projects are more conventional. They are regular C or C++ code that you can extend. You can write macros and automate a lot of stuff using Lua. Embedded systems, there is a lot of, I mean, Lua is embedded in TVs, in routers, in keyboards, in cars, a lot of, several car panels from Volvo, Mercedes, and other builders have Lua inside. Printers and calculators and, of course, cellular phones, Internet of Things, and all this stuff, again, use Lua. As I said, Lua, in this case, the main qualities are it's very portable, it's very small, and as I said, it's very, I didn't emphasize that part, but this idea of scripting, because you have two separate languages, you can control what the people can do in Lua. If you offer C for a non-programmer in an embedded system and he does a wrong call, he can even burn the hardware. And with Lua, you can control, you cannot do that, you can only do that, etc. It's much easier to control what you offer to the programmer. And games, this is a short list of games that use Lua. As I said, games is still, I think, maybe the main use of Lua. There is a lot of Angry Birds and World of Warcraft, and there's a lot of games that use Lua. And so, some perspective to finish the talk. Programming languages follow the art of the possible. I mean, all the time people tend I mean, it's hard to learn new languages. So people always want to use one language to solve all problems. There is this myth of general purpose programming. In the beginning, there was not like that. The old times we had Fortran for scientific, we had kind of domain-specific languages. We had Fortran for scientific stuff. Then they created COBOL for business stuff, and then there was Lisp for Lisp, more symbolic manipulation. And then IBM came with this big idea of a general purpose programming language, and then they created the language that will kill all the others. That's everybody here use regularly. That's PL1. So that was the idea. Why to have four different languages for all this stuff? No, we create PL1, and that language will solve all the problems. You don't need Fortran, you don't need COBOL, you don't need Lisp. PL1 will solve everything. And since then, since PL1, people are still trying to create general purpose languages. And what happens is that a language becomes popular because it is very, very, very good at one specific niche. And then people decide to use that language for everything else. Like C, for instance, is a perfect language to write low-level stuff, to write. It's not a perfect, but it's good enough or very reasonable to write an operating system, for instance, or to write disk drivers and stuff like that. And then, oh, see, it's very good to write. Why not to write web applications and everything else? And then all those problems we have, Stack Overflows, etc., because of an insecure language that allows you to do too much when you don't need to be allowed to do that much. and vice versa, and then you say, oh, Java now will solve all our problems, etc. And our idea is that these are myths. We have to have a focus, and you have, unfortunately, programmers, people have to learn different languages for different tasks. And Lua, since the beginning and through his evolution, has always been focused on being this idea of an extensible extension language. So that's what I had to say. Thank you.